Alright, now we're getting to some fun with antiderivatives. I'm not sure why the book doesn't present it this way with u substitution, but I think using u substitution really makes this a lot more simple. Now, some of you guys might be able to do it in your head because you see and understand the concept very, very well. But I'm going to go ahead and use something called u substitution because it's just a series of steps that kind of makes the process a little more smoother in taking the antiderivative. And so what we're going to do here is we're going to take the inside and we're going to set that equal to u. Oh, and by the way, the reason why we're doing this is because the function that you would take the derivative of to get this you would have had to use the chain rule for it. And so u substitution, I suppose, is essentially the chain rule backwards. Alright, so we start out with u. And what we're going to do is we're going to take the derivative of u. And to take the derivative of u, you would say du over dx. You're taking the derivative of u with respect to x. X is our independent variable. We get 7. And then we're going to do something kind of weird because it's not like we're really multiplying it, but it looks like we are. We're going to say that du equals 7 dx. And so when you do u substitution, you're probably not going to write this middle step, but it does help us understand how we got here. So u equals this and du equals this. And what we're going to do is we're going to sub out those two right there to then take the antiderivative of whatever we have with the u inside. Now, the u we can easily substitute in because the u equals exactly 7x minus 5, so we could put the u in right there. But the dx we can't simplify or substitute in really easily because du doesn't equal dx, du equals 7 dx. And so we need to have a 7 with that dx. So let me show you guys what we need to do. Give us a little bit more space. We have sine of u. U is inside now, the sine. And then we're going to put a 7 multiplying to the dx. So it's actually, sine u times 7 times dx. But we can't just put a 7 in there. We're going to have to undo it on the outside. But I'm going to put the constant on the outside. But now we have the 7 dx. And the 7 dx equals du, and that's what we need to take out. So we have 1 over 7. When I say take out, I mean substitute in. The integral of sine u du. So now I have du instead of the 7 dx. Now you can take the antiderivative of sine u. Now I'd like to take you guys back to when we took the derivative of cosine. When we took the derivative of cosine, we would get sine x, negative sine x. So what would give us a positive sine x? Well, if we took the derivative of negative cosine x, that would give us negative sine x, which would have the negatives would cancel out, so then we'd have a positive sine x, which is what we have in our problem. So to take the antiderivative of sine x, we would get negative cosine x. So now we have 1 over 7 times negative cosine u, and the du is gone now. We could plot our plus c there, but we're not finished with our problem. We have to get rid of this u. We got to go back to the x. So we just have to sub it in. So I'm going to have negative 1/7 cosine of whatever u was, which was 7x minus 5. And then we have our plus c. Alright, so that's the indefinite integral of that first trig function that you guys have seen. Now, I kind of want to test it because I'm kind of skeptical. We did all this junk right here with a u and a du. If we took the derivative of this, would it really take us back to where we began? Let's see. I want to see where we began. So we have the derivative with respect to x of negative 1/7 times cosine 7x minus 5, and we have our constant. Alright, so we have the derivative of that. The derivative of the constant really doesn't matter because the derivative of a constant is just 0, so we can ignore that guy. But over here, don't forget we have to use the chain rule. We have a function inside of another function. So I'm going to first take the derivative of cosine. The derivative of cosine is negative sine, and then I have everything inside of it. And that's multiplying times the derivative of the function inside the function, which is just 7. Now with some manipulation, we can go 7 times 1/7, and that would be negative 1. And then we have to multiply it times negative sine 7x minus 5. And negative and a negative would be positive, and it checks. We end up getting right back where we started. Now some of you guys will want to memorize this stuff, and so flashing it up here really quickly. The antiderivative of sine is going to be negative cosine. The antiderivative of secant squared x is going to be tangent squared, or I'm sorry, just tangent x. And actually, these should all look familiar when you think about doing the opposite of these. Like if I took the derivative of tangent x, that would take me over to secant squared x. But anyways, here you have it. It's also in your book, and it's also on the formula chart that I'm going to give you guys tomorrow.